So, dear students, today we will be studying about shifting of voltage source. You can see a circuit. In this, you can see two components, that is the resistor of resistance R1 is in parallel with an inductor of an inductance value L. In between the 2 points A and B, and the source capital V suffix S is being connected. So therefore, assume that R1 needs to be put in series with the source, that is capital V suffix small s, since two equal voltage sources can be paralleled, means this does not in any way affect the potentials of the points between A and B, that we had taken the parallel network of resistance or the resistor R1 and the inductor L. So you can just visualize the network, how we are going to use the shifting of voltage source. So here in the first one, you can see that the two voltage sources are being connected in parallel, as it is already been known that two equal voltage sources can be paralleled. This does not in any way affect the potentials of the points A and B. And in the next one, you again reduce it so that at the final you can see the voltage source is in series with the resistance and the inductor. This is how we are using the shifting of voltage sources for the simplifications of our calculations in the network and for the accurate measurements. We'll just have an example further. Consider the part of the network in between the points A and B, the two impedances Z1 and Z2. So the voltage source can be individually connected. So you can have a glance. So how the sources can be connected. Again, in the next slide, you can visualize the voltage source V1 that can be connected to three different impedances. So in this fashion, we proceed for the shifting of the voltage sources. Now the shifting of current source, you can see the network. So here the care must be taken to ensure that consequent shifting of the current source Is, the current distribution is not affected at the nodes. Just see the direction of the arrow mark, the current direction, capital I suffix small x, extreme on the right hand side, which is going to terminate at the node or at the point or end at the point A from the point D. So draw the next networks in such a fashion that the current ends or tends towards the terminating point A from the points D to C, C to B, B to A. So that is how we are going to shift it. This is very clear in this particular diagram of the circuit. So this is how we do use the shifting of current sources. So in a similar fashion, very next example you can have. So if in a network there is no single impedance in parallel with current source, the shifting of the current source is required. So this is how we are going to shift the current source by connecting in between the two impedances. There is no alter, there is no change. So again, the last one, you can have a visualization of this. It's exactly similar to the example that was quoted in the first example. It is the exact similar or vice versa for that one. See the terminating point of the direction of the current with respect to the nodes, and hence you can use these methods for shifting of current sources. Thank you.